right, today we're starting 8.2. We're graphing quadratic equations in the form of y equals ax squared plus c. A quadratic in the form of y equals ax squared plus bx plus c we talked about yesterday. Yesterday we didn't have a c value. Today, or our c was 0, and today we do. So we're going to talk about how that changes the graph. So first we're going to graph g of x equals x squared minus 2. So we're going to identify our a, b, and c. A equals 1. B, you can see you don't see a bx value, so b is 0. And c is negative 2. Just like yesterday, the first thing we do is we find the vertex. The x value of the vertex is negative b, or the opposite of b, over 2a. So to find our x value of the vertex, we would do 0 over 2 times 1. The x value of a vertex is 0. Okay, so our vertex is going to be 0 comma something. Taking that x value and substituting it back in, we would have y equals 0 squared minus 2. The y value of our vertex is negative 2. So let's go ahead and graph that. And just like yesterday, now we have to find more points. So we're going to start our table. Our vertex is 0, negative 2. Just like yesterday, we're going to pick x values that are close to the vertex but on the same side. So we're going to start with an x value of 1. When our x value is 1, we plug it back in, and we have a y value of negative 1. So 1, negative 1. Let's use an x value of 2. When we plug 2 or substitute 2 into the equation y equals x squared minus 2, we have a y value of 2. Okay, so 2 comma 2. And again, just like yesterday, our axis of symmetry goes through the vertex, and we're going to go ahead and reflect those points on the opposite side of the axis of symmetry. Okay, 1 unit away from the axis of symmetry, 1, 2. 2 units away on the other side. We draw a smooth curve. Okay, our axis of symmetry, or AOS, axis of symmetry, is a vertical line. The vertical line going through the vertex at x equals 0. Okay, if you look at this graph, since it opens up, the parabola opens up, it's going to have a minimum, okay, a minimum y value. Let's identify that. And in this case, our minimum or lowest possible y value is negative 2. All right. When we compare the graph to the parent function, f of x equals x squared, the only thing that's different in our graph is that our c value is negative 2, where in the parent function it's 0. And you can see, if we graph the parent function, the vertex would be 0, 0. So that c value translates our graph 2 units down. Okay, so when we compare that, the c value, okay, causes a vertical translation up or down. We didn't have that yesterday. Yesterday we just had a stretch or a shrink. So in this case, a c value of negative 2 causes a vertical translation two units down. Okay.